In this video, we will go over a couple of gravimetric analysis calculations. Gravimetric analysis is just a fancy way for determining quantities based on solid precipitates. For example, how many grams of solid silver chloride is formed when 25 milliliters of 0.5 molar solution of silver nitrate is mixed with an excess of sodium chloride? Well, here's the reaction. What are we actually trying to do here? With 25 milliliters of silver nitrate, we're trying to determine the mass of silver chloride that is formed. Again, assuming an excess of sodium chloride, so this is not a limiting reaction problem. But as you recall, anytime we want to go from one component of a reaction to another, we need to go by way of moles, and we use the stoichiometry. Now normally, to convert between moles and something we're given, for instance mass, we would use molar mass, but we're not given mass of our silver nitrate solution. We're given volume, so we have to use molarity in order to calculate the number of moles. So using this equation, molarity equals moles per volume, or specifically moles per liter, we rearrange it to calculate moles by multiplying volume times molarity. So we start with our 25 milliliters of our silver nitrate. Now remember, concentration is in moles per liter, so we have to convert our milliliters to liters. Once we've converted milliliters to liters, then we just multiply times molarity, and of course the units of molarity are moles per liter. And so milliliters and liters cancel out, leaving us with 0.0125 moles of silver nitrate. Now that we have the number of moles of silver nitrate, we can use the 1-to-1 ratio of silver chloride to silver nitrate to calculate the number of moles of silver chloride. And then from moles of silver chloride, we calculate the mass of silver chloride. Check your dimensional analysis, and everything should work out. In example 2, we have mixed 75 milliliters of a lead nitrate solution with an excess of potassium iodide. We have isolated 22.5 grams of solid lead iodide, and what we want to determine is the concentration of the original solution. Well, this is the exact same thing, except now we're going backwards. And we're not determining mass or volume, we're determining concentration. So again, we need to convert everything to moles, and going between mass and moles, we use molar mass. And again, when going between moles and volume and concentration, we're going to use our molarity equation. So we start with our 22.5 grams of our product. We convert that to moles of our lead iodide, and then using the 1-to-1 ratio of lead iodide to lead nitrate, we calculate the moles of lead nitrate. Now that we have the moles of lead nitrate, what do we do? Well, as we recall, concentration is just moles per liter, so we need to divide this by the number of liters we have. So we take that 75 milliliters, convert it to liters by dividing by 1,000, and divide our moles by 0.075 liters. In our last example, we want to calculate the minimum volume of 0.5 molar lead nitrate that is needed to precipitate all the chloride ions found in 25 milliliters of 0.75 molar iron chloride. So we're not calculating products. We are calculating how much of another reactant is required to completely react with the second reactant, iron chloride. So with our 25 milliliters of iron chloride, we convert that to liters and then multiply it times the molarity, check our dimensional analysis, and we find out that we have 0.01875 moles of iron chloride that needs to be precipitated. So we take our moles of iron chloride, and we use the stoichiometric ratio from the reaction equation, convert that to moles of lead nitrate, and according to our calculation, we need 0.028125 moles of lead nitrate in order to completely react with the iron chloride we're given. But we need to know volume. So we're going to take the number of moles of lead nitrate, rearrange our equation for molarity to solve for volume, and take the moles of lead nitrate and divide it by the molarity. Moles will cancel, leaving us with just liters. So the final answer is 0.05625 liters, or 56.25 milliliters of lead nitrate.